continue. The Arduino is just a little more complex with its circuitry, and you have to use a breadboard and more wiring than the microbit. Arduino uses C++ programming language, which is just a little more complex syntactically for students. So that's why we recommend Arduino for high school, microbit for middle school. They cover very specific, or they cover very similar topics. I just want to make sure people can see my slides here. Let's okay. Shout out in the chat if you can't see my slides. Just want to make sure. Okay. All right, so this course provides a highly interactive way for students to apply programming concepts to physical devices. So the course is meant to refresh and apply some of the basic programming concepts in the physical environment. So it uses the Arduino Uno device or a third-party equivalent. There's a lot of kind of knockoff different brands of the Arduino. So any of those are fine as long as it's similar to the Arduino Uno device. Throughout the course, students will test and compile programs using a computer simulator, which we'll get into, and they'll build circuits to run programs on the actual physical devices. So we use both, and both have their places in this process. So to simulate the circuits and programs, students will be using the software Tinkercad, which we'll spend some time today getting into. Then to transfer the programs to their physical devices, they'll be using the free Arduino IDE. And this is where they can really develop the C++ code and then transfer it actually to the physical device. And so we have created step-by-step documents that let you know exactly how to set these up and use these programs in your class. And I will share that resource with you in a moment. So kind of at the core of this class is that we wanted it to be a discovery learning class. And so really have students focus on getting in there, hands-on, learning as they go and doing some discovery versus just presenting them with information. So we've included these exploration activities into every lesson. So these are step-by-step documents that encourage students to hypothesize and then test how commands and sensors work with Arduino without directly being told by us or you guys. So we think this is important, helping students really think for themselves and become more comfortable with their devices. All of these activities are followed up by a video to ensure that they are getting what they need to out of these activities. So it's a little best of both, where they get to discover and then we help support that with a follow-up video. And again, we'll see an example of this. You'll go through an exploration in a little bit. All right, so let's talk about the structure of the course. So similar to all of our CodeHS courses, the course is broken down into modules. In this course, there's 3 modules. And then each module has a series of lessons. Normally, a CodeHS lesson would be around a class period of 2. These lessons in this course are going to be longer than that. So something to be aware of. And so then the lessons are broken down into activities. Unlike CodeHS courses, these are going to, unlike some of our other CodeHS courses, these are going to vary lesson to lesson. But they're all going to include some combination of a video, example, Arduino programming example, these exploration activities that I mentioned, and then exercises where students really get to build a program and a circuit. So you'll see there's a little variance in there, but they all generally follow that pattern. Okay, so because this is so different and we're using third-party softwares and physical devices, there's a lot of information, a lot of different resources. So we've compiled it all into one master document for you guys. So we're going to put this link into the chat and I'm going to walk through some of it. There's a lot of links pointing to a lot of different resources. All of them are on this document. So definitely bookmark this. This will be very important just as a resource for you. Okay. So let's get into this here. Okay, so this is this resource document. The first part is getting into a little more details of what I just talked through, generally the structure of the lesson and the activities. So as I mentioned, most lessons will include that video and video quiz, some sort of check for understanding. There will be an example where it's a pre-programmed Arduino code, and students can copy that code into their Tinkercad setup or their Arduino IDE, and then run those programs without having to write it themselves. So this is a way to see something in action, explore it. You guys can do a lot with it, and we have ideas in the lesson plans in terms of doing a guided explorations to breaking students in pairs. Yeah, there's a lot you can explore with these examples. Then we have pseudocode exercises. And so before they get into the actual building, there's often an exercise where students have to write out their program in kind of a hybrid English coding language, which we call pseudocode. And so this is a great way for students to get familiar with the concepts and the tasks and start with a framework before they get into the details of actually programming with the syntax and building the circuits. And then we have our exploration document, which I just talked about with the follow-up video. And these videos are usually pretty short. And then we have the exercises. So the exercises are where students will actually then build on their own to complete a task. We'll provide instructions for them to work through this. So again, it's a little different because the code that they will be building doesn't actually run on CodeHS. So there's slightly a different flow. So the process would be on a given exercise, they would open the exercise in CodeHS where they'll see the instructions. They would go to their Tinkercad account and then use the simulator to build the circuit and then start programming so they can test very easily without having to deal with troubleshooting the physical connections with Arduino. Once they've done that, and you can build into your process whether you check that step or not, they can then copy their code into the Arduino IDE and transfer that over to the Arduino circuit that they actually build. So once everything is functional and it's good to go, students then could copy that code into the CodeHS exercise where the instructions are, and that will be saved right there. And then you can grade it and track progress there. So CodeHS can still be the go-to spot for tracking progress, grades, etc. But Tinkercad, they can start developing the code, and I'll show you how to set up a classroom so you can actually run their code through Tinkercad. And then Arduino software is where they can transfer it to the device. So it's slightly different. CodeHS is still kind of the backbone of it all, where they'll get instructions and they can get their grade, but the other two will support that. If you have questions on that, definitely add it to the parking lot and we can address them. And you'll see some of these tools too at the end of the presentation. So the resources. Because this is a physical device, you need materials. Thankfully, let me open this up here. Most of the materials on this list are under $5 for a pack, and you'll get a bunch with these. So you can click through and see all that's here. These are the materials that we use throughout the course. There's obviously a lot more that you can get. Our recommendation, if you're starting fresh here, at the bottom, we link to a couple Arduino kits. These are the most cost-effective way to get the Arduino board, and then all of the sensors and wires that you would need to actually run the exercises. And they tend to be more cost-effective than if you were to buy everything independently. We also recommend students working in groups of like 2 or 3. And so you don't necessarily need a kit per student, but having enough where you could break them into small groups. So the individual items are listed here. The kits you can see at the bottom. There's a variety that you can explore. And that's just part of the physical computing course. Again, it's different than what we normally do. You will need some physical elements. So some of these other resources, we have created a quick Arduino reference document. And so this is a great spot to go to look up Arduino commands and just get some quick help with Arduino itself and the programming. What's awesome about this course is that all of our lesson plans are free, even if you're on the free plan. This is not true for, I don't think, any of our other courses other than Microbit. And that's because you really need the lesson plans and these resources to be able to run this course. So that was a decision we made to get the resources out to you so you can teach the course. So here's the link for all the lesson plans in the course. They're all available. We'll spend some time looking through them today, but that's a huge resource. There's a lot of information there to help you use these in your class. So we've got this request from teachers, so we've provided this access to quick links for all the exploration documents and handouts in this course. Again, they're all free, but we also provided direct links to the Google Drive folder where all of the handouts are. So if you wanted to print them out all in advance, you could do that without having to click through the course. So it's just a quick and easy way to get all that information. And then we have, similar to other CodeHS courses, we have problem guides. These include a little more details about the solution of the exercise and FAQs, common things that come up when working with students on particular exercises. So definitely check those out. And finally, we have here the reference sheets for the 2 softwares that I mentioned. So Tinkercad, step-by-step in setting up the work in Tinkercad and your class in Tinkercad, which I'll do a demo of, and information about installing the Arduino IDE. And of course, if you still have questions, you can always reach out to us and we can help with that. But hopefully this is helpful. It combines it all into one place. Definitely bookmark it and use this as a reference guide as you're starting to get into this course. Okay. All right. So specifically, let's talk about the modules here. There are 3 modules, as I mentioned. The first module is really the basics. So students learn the basics of a device by controlling LEDs, motors, using variables to structure their programs. So it doesn't get into too much complex programming off the bat. The second module is where students will actually apply control structures to their programs, along with using new sensors and additional components. They'll use things like temperature, light, distance sensors to detect the environments around them, around the Arduinos. And they'll have their programs make decisions then based on this information using those programming control structures. This advanced module, which we'll go into more detail in a moment, we'll really dive into this, but this is where students will get to apply all of their skills that they've learned in completing more complex problems or projects. So they'll do some independent research on sensors, complete an existing project that's online, and then eventually they'll be designing their own. So even though it's 3 modules, don't be fooled. Again, these lessons are longer than normal. This is designed, again, for a semester's worth of material. So one of the things I mentioned is that the goal of this course is to refresh some programming concepts and then apply them to the physical world. So we're not going to get into concepts like loops, functions, conditional statements, variables from scratch with this course. So students will have to have seen some of these concepts before. We have a variety of different course options that can provide that prerequisite information. So everything from our intro modules with Carol and Tracy, and then our full courses, Intro to CS with JavaScript or Python, and then our two AP courses. So there's a variety of ways to do this. Just know that our Carol module doesn't get into variables. So you would have to supplement that with some additional information from our JavaScript course or another course about variables specifically. So a couple ways to implement this. Students can have taken this course prior to starting your course. So either they've taken a programming course, in a previous year. Maybe you have a summer assignment, especially using Carol or Tracy. That would be a great module for that. Or if you have a year-long course, you could do programming in the first semester of your course and then Arduino in the second semester of your course. So that's one option. The second option is that they are taking programming concurrently with the physical computing. So whether it's in another class period, if it's you or another teacher, or you can thread this into the current course if you have a year-long worth of course to work with. So we actually have two courses that we did that for you. So in the course catalog, we have Intro to Programming in JavaScript and Python with the Arduino, and essentially just took the three Arduino modules and merged them into these courses where they're appropriate. So making sure they have the requisite programming knowledge before they take on these Arduino units. So something to keep in mind. All right, so that's the overview. A lot of information. Hopefully that was helpful and the resource page is helpful. The rest of the time I'm going to have with you is to look more specifically at a lesson and then get into a little more of that advanced module so you can really see what's in there. If you joined since we started, be sure to sign up on CodeHS or sign in and then enroll in our workshop section. We'll put this in the chat again. We're going to be doing some activities in this part. So you're going to be watching video and doing some activities yourself. So I encourage you to enroll in this section. You can always do it later too, and you'll have access to this. But we will be spending some time working through these activities right now. So I'll just give you 10 seconds to do that, and then I'll introduce the lesson. Okay. So this sample lesson, this sample part, we're going to talk through one lesson in one module. So the lesson will be the first module in the course. So this is lesson 1.1, and this is a great, I think it'll be hopefully helpful to see how things are introduced and set up. And then we will talk through the advanced Arduino and just get a little more details on that last module. So the goal here is to demonstrate how lessons are structured in this course, because they are a little different, and talk about ways that we can integrate them in the CodeHS platform and present them in different environments in your classroom. All of your classrooms are going to be different. I think most will be in person this fall, but who knows? That could always change. So we're going to talk through just a variety of ways that you can implement these activities and then have time to discuss with each other and share ideas. Again, let me reiterate, all of our resources for this course are free. So we're going to give you time to explore the lesson plans and resources at the end here. Okay, so this first lesson here. So as you can see immediately, this lesson's a little bit longer than other CodeHS lessons if you've used our other courses. So they usually will fill anywhere between 1 to 3 class periods, depending on how much time you want to give students in the explorations and diving deeper into the exercises. So this lesson in particular has 3 parts. The first 3 activities are introducing students to the Arduino, and it's a chance to discover some cool projects right off the bat, which I'm going to have you guys do. The second part, we'll introduce Tinkercad and do an exploration with a simple circuit, and you'll get to experience that. And at the end, this lesson is going to give students an opportunity to reflect on their past experience, their interests in physical computing, and some goals for this course. So you'll get a chance to experience them as a student, and then we will talk about as we go ways to implement them. Okay, so to start here, I'm gonna have, we got a lawnmower situation. This is great. You're gonna be working independently. So I'm gonna have you watch the first video on your own independently, and then go through these 2 free response activities. And this is a chance to learn about the Arduino and explore some cool projects early on. So if you're in there, you'll see that they're locked right now. This is something I'm gonna demonstrate after we talk about the course in the tool section, but this is our access controls tool on the site. So I have locked everything so you guys couldn't start before I wanted to. So it's a way to control the flow. So I'm just going to unlock now these first 3 activities. If you're already on the page, you're going to need to refresh your page to get those activities unlocked. If you're not, go to My Sections. Oops. Go to My Sections. And then the 2021 Summer Arduino Workshop. And you should see the list of modules and the lessons and assignments. So in that first lesson, I want you to complete the first 3 activities. And again, if they're locked, just refresh your page and they should become unlocked. So we're going to give you a little time to do this. I might have to cut you off just for the sake of the workshop. But I want you to at least see what's in there. So go ahead and watch the video and complete the first 2 activities. Looks like most of you are on to the third activity, so I'll just give another minute or two so you can have some time to look through that example. All right, awesome. Thank you for going through that. Hopefully that was helpful to see that and you got to see some cool Arduino projects. I personally, I love Arduino. There's so many things you can do with it. So to get students excited by this activity or this setup early on, I think is really important because it can be taken in just so many different directions. And we'll talk about some ideas around that and what you can do with your students. So let's continue here with another poll. So if we go back to Slido, and you can now use the code CodeHS 2 as the code. And here's the QR code. So this is just a free text activity, just to kind of brain dump. What's something new that you learned about the Arduino in these activities? So a lot of you haven't used Arduino much at all. Some of you are experienced. So having watched the video and clicked through those activities, what's something new that you learned about the Arduino? Again, you can use the QR code on your phone, or you can go to slido.com and use the code CodeHS2. Cool, large variety of sensors available, absolutely. There's so many things you can do. Yeah, I agree. I wish I had more time. I want to make more time to really get into it. I do a lot of gardening and I've been meaning to see what I can do with like moisture control and temperature control. Yeah, more than expected. Yeah, it's similar to Raspberry Pi. It's a little simpler just as a controller, but there's a lot you can do. Creating many projects. Nice. So it seems like a theme here. There's a lot more that you realize you can do. And that's the point. Like by starting off this course with students and really leaning into this, like see where students' interests are. Keep track of that. Maybe have a document where you can start listing interests, or maybe they can submit it to you. So you have a sense of what they're interested, whether it's science or gardening or robotics, or just like fun engineering. You know, there's many different ways to go with this. So yeah, it's great seeing this. All right, cool. Let's jump back in here to the lesson. All right, so in terms of implementing this section of the lesson, so we had the video and then we had some discovery activities. And so what I chose to do is have you guys watch it independently in class and then share after. So I did this Slido poll just to get some input from you all. Obviously, if you're in person, you can have a discussion, or if you're virtual, you can have a live discussion. So this is one way to do it. You could also have them do this very easily as homework because all they need is the video link and then the website link. So they don't have to do any Arduino specific things. So it's a great idea for flipped classroom. They could do it on their own. Of course, you could watch the video live together and maybe do the exploration in pairs or groups so they get to talk to each other. We also offer all the slides in our videos in the lesson plan. So you could incorporate the video slides into your normal presentation. So you could present it and talk through it and present that information and maybe have a little more Socratic discussion around these ideas as you're going through the video content. So some alternative ideas as well. I mentioned creating a list of projects. Again, I think the goal early on in a class is really to get students excited and use that energy then through the rest of the course. So maybe it's creating a document that students have ownership of. They can list projects that they found were exciting and want to build by the end of the course. And you can mention, hey, at the end of the course, you're going to get to choose a project and build the entire thing. So this could be a good place to start keeping track of exciting projects. We also have in the lesson plan, which you'll see, a scavenger hunt handout. And so what this is, you can set up Arduinos with programs and a simple circuit before class. And then they're doing kind of a hands-on exploration right in the beginning of the lesson. So again, a way to get students excited without getting bogged down by the details. You can have this set up. We have a document that asks them guiding questions and they have to figure things out before you even get into like the discussion. So, start off with some hands-on activity. And then the SESME activity, you could set up. It's a little more complicated in the setup, so I wouldn't necessarily recommend students building it day one, but you could have them pre-built, maybe 1 or 2 or 3, and then pass them around the class so they get to experience and try the memory challenge and see how well they do. So connect them to that physical device early on. Yeah, those are just a few ideas how I might alter some of what's we covered already. So the middle part of this lesson now is actually getting into Tinkercad. So this first lesson doesn't get into the physical devices other than the demos that maybe you want to set up, but it does get into Tinkercad. So I'm going to demo this live, and then you're going to have some time to either sign in or create an account yourself. Okay, so let's see here. Tinkercad is awesome. The whole AutoCAD company is, or Autodesk company is, they have a lot of interesting things. And so they offer this software, Tinkercad, for free to design. It's a design element, everything from 3D printing to circuits, which is how we'll use them. And I apologize if you can hear the lawnmower. Timing is always wonderful. So I'm going to walk through just signing up because you can sign up as a teacher, which is really cool. So start tinkering, educators start here. So I'm an educator. This just provides some information of when you create an educator account and students join your classroom, they have what's called safe mode, which just limits some functionality as students versus normal, and you're able to moderate their abilities there. So I'm going to click continue, certified I'm an educator, agree. All right, so I'm going to sign up with email. I'm just gonna make up a birthday. It's not my real birthday. I know. I'll ballpark it though. We'll get it in there. Okay. So Ryan at codehs.com. So doing this live just to show you how simple it is. It's very easy. One of the challenges just in general is getting students on a platform, sign up, software, etc. So CodeHS is nice because all you need is the web browser. You don't need any plugins or external software. Tinkercad makes it also easy because as a teacher, you get this link up here called classes. So you can set up a class here. So I'll do that now. Classroom name, let's say summer workshop, grades, in this case we're other, subject, we're learning some computer science. I'm gonna create this class. Okay, so here's my class. If I click on it, this is what's really cool. So you can preload, there are a couple ways to get students into the class. You can preload students. So their name, Ryan, and then you're gonna give them a nickname. And this is a nickname that they'll need to actually join your class. So depending on what you do with student privacy or name, some change it, or you can just do, maybe their last name. So I'll just do my last name as my nickname, save changes here. You can also paste all your students at once. So essentially what this does is it creates like a username through that nickname, and then you have a class code. I can click this and see it's bigger. So students don't need to sign up for Tinkercad to get started. So they can just go to tinkercad.com and then you'll have this join class link. So with the class code and then the nickname that the teacher that you guys assign to them, they can just slide right into your classroom without having to go through an account setup process. So it's a super easy way to get in the classroom. The classroom enables you to view the student programs and run them. As I mentioned before, this is the place to be able to run student programs from your own computer. So that's a very easy way. If students already have an account, we have a document too of how they can use the class code to join. But Tinkercad Autodesk created a very simple way to join a class without actually having to create student accounts for everyone. So it just simplifies that process a little bit. All right, so let's go back here and actually show you the setup here. So as I mentioned, there's Tinkercad does do 3D design, 3D modeling, but we are interested in circuits. So I'm going to click on circuits, and I'm going to create a new circuit. So there's a few pieces here. We have our workspace, the big gray space, and then we have our components list. So this is going to be very similar to the components you're going to have in your physical setup. So I'm going to, actually, before I get started, just a couple things. When you create a project, it kind of gives it a random funny name. So you can have students name it accordingly, however you want. So maybe this is first exploration. And maybe you want their names, and then you'll be able to see, each student's program, but I always think that's a good practice there. Okay, so we're working with Arduino, so I can just click and drag this right in here. With each component, when you add, an info box with, depending on the component, pops up, and you can change some properties. You can also rotate the device around if you want to. Oops, went too many times. Perfect. Okay, so for our first circuit, let's take an LED. So an LED is a light emitting diode. And you'll notice in the physical form, there's a long end and a short end. Those are very specific ends, and they have to be connected in the right way in order to work. They vary on colors, they vary on internal resistances, but it's a very simple digital device that emits light when connected to a power source. You often need what's called a resistor when running an LED to control how much current is actually flowing through that LED. Resistors vary by resistance with these color bands, which we don't talk through the course, but it's a great supplement activity, which I'll mention. You can change the resistance right here, manually typing it in and choosing the unit. And you can also change your color of the LED. So let's connect this. I'm going to rotate this here a little bit. Let's try this. I can always change things. So I'm going to click on the long end here. And I'm going to connect this. Oops. I'm going to connect this to my 5-volt power. And then I'm going to connect the other end to the resistor. And then the other end to the resistor to one of my ground ports. So this will complete my circuit from the positive side of power all the way down to the negative, the ground. I can click on each wire and I can change the color of the wire. So I can give this a red, and maybe this one will leave green, and this one I can turn into black. I can also double click on a wire and it produces, new points. So if I have my thing way over here, I can kind of design a neater looking circuit. Something like that. Maybe I'll add another point there. So now I can actually run this circuit. So if I click the start simulation, you'll see that it lights up. There was no programming involved. I connected directly to a power source, positive and negative. I have the resistor, and there's enough current to light up the LED. So a very simple, basic circuit. Okay. So I think that is all I wanted to show. Yeah, cool. So now we're going to get you guys signed up here and doing the first exploration. So your task now, we're going to break you into just smaller breakout groups, but we're going to have you sign up for Tinkercad, create a class, and then create your first circuit. And you're going to do that with our first exploration document, which is in the lesson. It's this connection activity. So I'm going to go through here and I'm going to unlock these activities. So I'll unlock the video too if you wanted to look at it, and the signing up document to see what students would see. So if you want to refresh your pages now and open up the connection exploration document, this Tinkercad document. And we're going to give you just a little time here to sign up. If you haven't, sign in. If you already created a personal account, you can switch it over to a teacher account, and that'll just unlock the classes mode. So you can do that through your profile. You can select what role you have. So we're going to break you into breakout rooms. And you're just going to work through this exploration document, sign up, and then work through this exploration document in your breakout room. And then we'll call you back again. You might not have all the time you need to complete it just for the workshop. We want to make sure we leave enough time, but you definitely have some time to get into it. So Julia, I'll leave that to you then. Awesome.
All right, your rooms are open.
All right, welcome back, everyone. Make sure I share the right screen. Awesome. Hopefully that was helpful. You guys were able to get into Tinkercad and start to see the exploration. We'll just wait for everyone to rejoin the main chat room. Okay, it looks like people are trickling back in here. So if you didn't quite get to the exploration, that's okay. It looks like most people did, at least got to open it. This is a big part of the course, using the explorations. We want students to be discovering on their own, to be forming a hypothesis and then being able to test it. Because we want students to get it wrong and then see, oh, that makes sense, or I don't get it, versus just being presented with information. So much, I mean, as the name suggests, is tinkering. And so really emphasize this time. I mean, this is a simpler one, but some of these explorations really could be a class period in themselves, just getting students to explore and try things. So let's, I just want to show you really quick what the exploration follow-up video is. It's very quick. I think this one's only 30 seconds. So let me just play this for you, just to get a sense of what it is.
Hi, you just completed an exploration where you used 2 new sensors to control your programs. Let's summarize what you learned. We learned how to use photoresistors and thermistors to control our programs. Photoresistors provide a value of 0 when the sensor.
And I just realized this is not the right follow-up. So let me see if I can load this really quick. Oh, I'm in totally the wrong module. Okay. Hold on 1 second here. This is what I wanted.
I was like, wow, we really got far in the first lesson.
Really just accelerated through this course. All right, so this is the exploration video.
Hi, you just completed an exploration where you built your first circuits on Tinkercad. Let's summarize what you learned. We learned that we build circuits in the large area on the left side by dragging in components from the library on the right-hand side. We also learned how to use the buttons on the top left-hand toolbar to spin components and add notes. We learned that when an LED is connected directly to the ground and 5-volt ports of our Arduino, too much current is flowing through the LED, which can be dangerous. In the case of a tiny LED, the bulb will get pretty hot and can burn out from this excessive amount of current, but with different components or when using a more powerful power source, this could lead to a fire or explosion, so we need to be very careful when connecting components to our Arduino. We learned that to safely use LEDs, we should include a resistor in the circuit to limit the amount of current flowing through the component. We also saw how different resistance values can affect the brightness of an LED. This information will be important as you continue through the course and build virtual and physical circuits of your own.
Yay. So again, they discover, and then there's the support so that we make sure they're getting what they need to in order to move on with their understanding. Okay, so let's talk through some of these. So with the video and exploration, these last activities, again, you could have them do an independent class. You could have them do it as homework. In this case, I wanted to do the Tinkercad as a live demo instead of watch that video because I wanted to talk through it. If I was in person, maybe I would have you guys follow along and do it at the same time. And then do the exploration in groups. Some of you might have just been working on your own, but at least you had each other. You could ask questions as you were doing it. So that was a conscious choice I made, especially as you're signing up for something and doing something for the first time. And then watch the follow-up video as a class, which I just showed you. You could follow up, on your own, presenting the same content using the slides that we have in our deck. So a few different ways to implement that piece. And then some supplement ideas. We've linked to information about learning more about the color resistor banding, resistor color banding. That's not something we get into this course, but it's a great kind of extension. So depending on what you want to focus on, you can really dive into more of the physics and engineering pieces of the Arduino. So talking about resistor, color banding, the amount of resistance, what it does, how it affects current, voltage, how that plays an impact. We don't really get too deep into that. So there's always room to expand in that sense. We also have a handout where students could take inventory on the parts for their Arduino, so they start getting familiar with what are all the different pieces and sensors that they'll be using. And also doing some programming practice. They don't need programming right now. And so now could be a good time to review some concepts for the upcoming lessons. We have practice on CodeHS, so they can just practice problems. You could also enroll them in a course or choose certain lessons you want them to work through. So there's a variety of ways to get some of that programming practice, again, as supplement. The lesson plans do a good job in highlighting some of these alternative activities. And so we'll get into that in a moment. So the final piece of this lesson is for them to reflect. This can be done, together, independently, in class, out of class, but it's very important. And so I wouldn't skip it. I think this is a way to really connect with students one-on-one. So maybe you schedule time, depending on your class size, to be able to touch base with students and what their interests are, because maybe you can then help them tailor projects that are going to be interesting to them, and get them thinking about what do they want to get out of their time in your class. We also have a handout in the lesson plan if you want to go deeper into the goal setting, so it has a few more guiding questions. Okay, so I do want to get you looking at a lesson plan before we talk about module 3. So we're going to do a quick breakout group session again. And you're going to look through the first lesson plan, and then there's just a few questions to reflect on this lesson and how you might implement it in your own classrooms. So if you click on this link, which we'll put in the chat, there are a series of documents, and I'll just show you that. And so just choose the document relative to your breakout group. So if you're in breakout group 3, open group 3 discussion questions. Sound good? So we'll give you maybe 5 minutes or so to just glance through the lesson, see what's in there, and then talk about one or a couple of the questions in the document here.
Awesome. Hopefully you guys were all able to have a good discussion. I love being in that role where I can sneak on you and see all the thoughts that you have. So great ideas that I saw in those documents.
Cool. So yeah, definitely, hopefully you got a sense to see what's on the lesson plan. Just to reiterate, they're all available for this course. So there's some awesome things there, everything from, just timing on activities, discussion questions, and things like state standards. If your state has a physical computing course that has some standards around it, most of those are mapped through our site as well. So lesson plans are awesome. And let's talk about this final module in the course. So up to this point, students have been learning through these first two modules about different components in Arduino circuits, different sensors, all through the similar structure of a video, of an example, exploration, exercises. So it's kind of a scaffolded process, but guided. So students are expanding their knowledge. They get to discover, build their resourcefulness, which is great. And I think there's a lot of room to dive deeper into these topics. And depending on your timing, you can feel that out with your students. This third module is a little more open-ended. And so I wanted just to take a few minutes to talk through this. So you have a sense, if you're teaching this course, you can kind of plan on it. So this first lesson is similar to previous lessons. They get to learn about LCD screens, how to connect and use them. They'll have a new library, which will introduce new functions and variables. And then they'll build a digital watch and elevator floor display with that LCD. So it's a little more complex than the previous lessons. So that's what we call it, an Arduino challenge, but it's still fairly scaffolded. So this is where I really like this module, and especially this course, because it is, I think, very exploratory, but in particular this module. So in the second lesson, they actually get to choose a sensor that they've never seen before. And there's so many interesting ones out there. You can kind of see in this bottom left here, just a selection of a handful of them. So students have enough foundational experience that they can now learn about these sensors on their own. They may need some guidance, they may need to do some Google searching, but they have enough knowledge at this point to allow them to be resourceful and kind of figure it out. So once they choose a sensor, then they'll actually create the education materials to teach their peers about the sensor. So they'll make a video or exploration document that presents the main concepts about the sensor. And then they'll develop an example that shows how the sensors can be used. And finally, then they'll come up with an exercise where students their peers can follow along and actually build a small project and program of their own. We all know, you really learn it when you have to teach it. So those who have not taught this course, you're really going to be learning it this semester. And so this is a chance for students to do that on their own, and they'll really become an expert on a particular sensor. And then if you have more time, students you can break them into like groups of 2 or 3, and then have students go through each other's content. So do the learning and then practice building those projects with the creator acting as the mentor or coach. If I were teaching this, I might take it a step further and then have students give feedback on education materials. So they're also kind of the meta of all right, not only did I learn about the sensor, but how do I present this information so that others can understand it? And these are high school students. And so, that's definitely something they can think about and decide how they would improve for next time. So that's lesson 2. Lesson 3, this is now when we get to return to those online projects that they saw, or that first activity in the course. There are hundreds of examples to choose from, all ranging in function and skill level. And so before we have students design a project of their own, it's important to be exposed to somebody else's kind of project setup. So they can go through the step-by-step instructions, they can do something totally new and see how it's structured, and that will provide some guidance when they then design their own project. I think it's probably best. Students can work individually, but I think in groups of 2 or 3, depending on interest and ability, is probably a good way to go here. You want students to be challenged and you want them to extend themselves, but it's, that's the art of teaching, is how do you scaffold it so it's still doable in the time that you're allotting for this lesson. And this will depend on, your classroom and what you have in your semester. But this is, something to be aware of. These projects at the end will take some time. So as you're scheduling your semester, allow time to do this, because this is where it's even more fun of, being able to tackle these projects. So this final lesson is where students actually get to design their own project now. So they've worked through all the sensor, learning exploration up to this point. They've worked through somebody else's project, and so now they get to develop a project from scratch. So they're applying all their knowledge of circuit and sensor and programming skills here. And so obviously there's infinite possibilities. So this lesson helps guide them through the design process. So everything from planning to creating prototyping, getting a quick prototype to get some feedback, testing it with peers, and then taking that feedback and improving and kind of going through this process in an iterative manner. So important. You don't want to get all the way to the final product and then realize like people have no idea what it's doing, or have a great idea and you wish you'd heard that week 1. So this is a chance to bring in some of those soft skills in the design process, which can be used in programming, can be used in any sort of design, anything from architecture, game design to robotics. This idea of iterative, quick developing, quick prototyping, quick feedback, and just going through that cycle again. So again, you can kind of plan based on your timing how much you want to leave for this. But I think this can be your final project in the course. We don't have, actually, I don't know, do we have an exam? I was gonna say we don't have an exam. Yeah, so we don't have an exam for this course. So this is the final assessment. So you can really lean in on this, and students will have to present their project to the class as well in the end. We have slides in there. You could do a video. You could do a teaching thing where each student gets a day to teach, their project. So that's up to you to kind of change that too to fit your students. So, so yeah, awesome third module. I love it. It's different than the other ones. It's a little more open-ended. So just be aware of that as you're kind of building these skills leading up to this point. Okay, so we're not going to do this final debrief just because we want to have some time to look at tools and allow for some exploration. I just wanted to show you this resource link again, though. Make sure you have it. It's bookmarked. One of the questions that was part of this discussion that I do want you to think about is, why are you excited about physical computing as a teacher? And you may be teaching this course by choice, or you may be politely forced into this course. But either way, I think it's, students will pick up on your excitement. So if you go in knowing why you're excited to teach this course, they'll see that too. And so as a follow-up, what can you do to help get students excited? How can you empower students in this course? This course lends itself to student empowerment because there's so much discovery and tinkering and creativity built in here. So have a plan in place of how are you going to share this excitement? Maybe it's an elective course and you do a video or live demonstrations at an assembly or part of a morning meeting or something. How can you help bring student projects to a larger audience to get them excited about it? So just something to think about. as you're going into this. I have seen some really cool, like computer science engineering days were during a lunch period, and it was in a gym. A teacher coordinated this whole kind of demonstration of student projects, and other students could come in and see them in action and play with them. So it was really neat. So even though this is a semester course, depending on your school setup, something like that is really fun. Okay, cool. So to finish off here, I'm going to pass this back to Julia to explain what we're going to do.
Awesome. So also that resources link has been added to the parking lot. At the top of the parking lot, there's a lot of helpful links right there. So that resources is going to be available there. And I know some of you are noticing that other parts of the course might be locked, but they will be unlocked so that you can access them. So don't worry about that. Brian was using one of our access control tools to make sure that we all were focusing on the specific part of the lesson that he wanted us to. So now you'll have all of those parts of the course available. Awesome. All right, so for our last little bit of time here, we are going to look at some tools and resources. But if you have joined us for any of our other summer workshops, you may have heard this spiel a few times, and we want to make sure that you are able to choose how to use this time the way that you want. So in this main room, Ryan will actually be in here, and he's going to lead us through some tools and resources to show you what you have available on CodeHS and how you can access some of those tools that he even was using during his lesson. So if you wanted to listen to that tools and resources, you can hang out in this main room. That's going to be called the campfire. And the second breakout room that you have the option to join is the watering hole. And this is a space where you just have an option to chat with other teachers. I know you had a few breakout rooms today, but it seems like there were a lot of great discussions going on. And it's always so valuable to be able to talk to teachers who are in similar scenarios to you. So if you would like to do that, you can head to the watering hole, and I will be in that room as well if you have any questions about our Arduino content or any of the course that we just looked at. And the cave is going to be your last option. That's going to be another breakout room where this is more focused on independent time. If you are just like, I am so overwhelmed, I want to try this stuff out for myself, this is a great space to go. And Ursula is going to be in that room. So if you do have any questions, or you get lost, or you're looking for something that you can't find, she will be in that room to answer those questions as well. So I'm going to open our rooms, and this will not assign you to a room. So if you go to your participants tab, you should see at the bottom of the list, there's watering hole and cave. And the way that you join it, if you look on the screen, our image at the top, you actually hover your mouse over the blue number next to the room you want to join. Right now, they're both at 0, but once you hover over the 0, it will switch to a join button, and you'll be able to click join to get into the watering hole or to the cave. So we're going to give just a few minutes, because we definitely want to be able to have this time to show you tools and be able to have time to explore and ask questions. But we'll wait a few minutes. If you are having any issues joining the separate rooms, awesome. So the way that you get into the watering hole, if you have the participants panel up, you should see watering hole and cave at the bottom, and you should hover over the number 0, and it should switch to a join button. And if you click there, you can join. But I can move people also directly into those spaces. So if you want to let us know where you want to go, just write it in the chat and we'll move you in there. And we'll just wait a few minutes so that we can get everyone into the prospective spots where they want to be. Awesome. I see lots of people joining. So me and Ursula are going to go and join the cave and the watering hole. You can use the chat to let Ryan know for the next just few minutes if you need to be moved somewhere else. All right. And we'll come back together for the last few minutes just to give you our last wrap up information.
All right, awesome. I'm just going to allow a little time for those who want to shift. Again, I don't know if you see a participants button or a breakout rooms button. Yours might look slightly different than mine, but I'm happy to move people too. All right, Iris, I can move you over. Iris, all right, bye, Iris. Campfire will stay here. Campfire. All right, okay, cool. All right, I think everyone. So if you're here, I'm just going to give a very brief overview of some of our tools on the site, just in 10 minutes or so. So you have a sense of what's there. There's a lot. Our site has a lot. And a lot of our tools have been developed from teacher requests. So let me unshare my screen really quick here. I'm just going to move things around for a second. Okay. All right. So let's get into this. So I'm just going to, again, it's going to be a lot. If you haven't used CodeHS, we have resources to support each tool. Some of these are part of the free access. Some are part of the pro access. In general, you can think about kind of the nuts and bolts are free. If you need to do something with your class as a whole, like look at your whole progress as a class or the grades of all students at once, that generally is part of the pro package. So really the classroom management, like the access tool, controlling content, locking it down, releasing it, that's all going to be part of the pro. So in general here, CodeHS is set up based on section and courses. So courses hold the content, sections hold the students. And so when you create a new section, you're going to be creating a section of students, and then you're going to align it to a course. So this is a demo section for JavaScript that I created here. So it has all of my students listed in the roster. So this is section information, and you can see it's aligned to the JavaScript course, which I'll show you what's in that course, in a moment, so you can see the assignments. But this is the section. So in the section, there are a few things you can do. There are, first of all, you can see students being listed. There are student settings here that you can go in and modify, help them with passwords. So kind of just managing your roster here. If I click the conversation tab, this opens up a space that I can have a running flow of a conversation with a student. And this is not exercise specific. There is a way to converse through an exercise. So it's linked to that exercise, but just through the roster page, you can send messages back and forth. And students will see that they have that new message. You can also send an announcement to everybody in the class. So if I clicked announcements, that would bring me to this page where I can maybe just post some information. Everyone in the class gets that information. And then we also have an attendance. You can see when students are active on the site. These are especially important if you have a virtual setup, over the last year. If you're in person, you might not use them as much, but just wanted to show you they are there. So from my section, if I want to see the course that the students are enrolled in, when I created this section, I would click the assignments link. Before I mentioned that, I forgot to say this. To get students into your section, you can use this URL. This is the same thing that you guys did to get into my section of the workshop course, or the workshop, section in course. So you can send them this URL. If they don't have an account, they will be prompted to set up an account, and then that's the class code to actually get into the section. Okay, so if I click assignments here, this brings up the assignments, the activity, the modules, the lessons, the activities, they're actually in the course. So this is our JavaScript course. And so there's a lot of modules, lessons, activities. Here's where you can work with the content. So you can move things around. You can actually create your own content and add it in here. You can even add content from other courses into your course. So this is like your copy. You can rename this if you want. This is your copy of the CodeHS course. And yours, will be for the Arduino. But you can really modify and control your content through this page. You can access lesson plans and settings all through this page. So that was the assignments link. Now to control this content, in the course settings, we have access controls, due dates. We have this combination due date access control. So I'm just gonna pull that up really quick here. So this is very important. When I was my first year at the company, I was on the teacher side. So I was working with teachers and helping, run their classrooms. So this was often the first thing that I had them do was think through how do they want the content controlled. So first of all, this assigned column determines whether these modules, lessons, assignments actually show up on the student page. So if I were to click no, this whole module disappears from the student's assignment page. They don't even see it. So if you want to hide things from students, you'd use the assigned. Access controls is what I use today to lock material down. So I didn't want you going ahead, or maybe you have a quiz, you don't want them to see the quiz, you can lock it and then make it available whenever you would like. You can also schedule things to release. So say you had a lesson and you wanted it to open tomorrow at a certain time, and then you wanted it to close tomorrow at a different time. So you could do that. So I've seen teachers use that for quizzes. Arduino course is a little bit different, but because we don't necessarily have those sort of multiple choice quizzes as much, but that functionality is still available. These are all part of the Pro package and managing, a whole class worth of content. The assignments page, a lot of this is free and being able to manage the specific assignments. All right, so from the, so this is content management. Progress management, we have a few different options. We have a progress by assignment, lesson, module, quiz scores, time tracking. So if I were to click the assignment tab, this is what I would see. So this is just a quick glance color code to see where students are on particular activities in each lesson. So gray means they haven't opened it, yellow means it's in progress, light greens means it's submitted but it hasn't received a grade, dark green means it's submitted and has a grade, and then these red ones are part of the kind of review process, where you can communicate it's reviewed and you want students to work on it more, or it needs to be looked at again by you. The student submitted it after you told them to review it. This is what I used in the class to see where you were working on the activity. So when I said, hey, work on these few activities, I could see you guys opening the activities and see and keep refreshing the page to see the progress and know when it was time to move forward. And so that's progress. If we want to actually do grades, I click on gradebook. And you'll see a similar view, similar colors, but now you'll actually see the score grades for all of the assignments that are in this module. To grade them, there's a few options. So we have most of these assignments will be manually graded because we don't have auto graders for the Arduino. So when it shows light green, that means the student submitted their activity, but it hasn't been graded yet. And so if I click on this link here for this activity, this is in the grade book, this opens up a grading tab. And so I can see all the submissions for this particular assignment, the time spent. Now, again, this is a little different because they're just going to be copying their Arduino code into the CodeHS editor and submitting it. But on another programming course, you could see how long they worked on it, the status of their assignment, and then any score that they've received. So there are a few ways now to actually provide a score. You can click view, and this will open up the student's assignment. You can take a look, and then you can provide a score manually through here. Or we have this fast grade setting. So if I were to click on fast grade, what it does is it pulls in all the submissions for that particular assignment, and it shows the student code and then our solution code. Again, this is going to vary. It's a little different for this Arduino course, but you'll be able to see the student code and then provide feedback and say, great job, and then give a score, and then click finalize if you want them to be done, or needs work, and that's communicating you want them to revisit and keep working on this. As soon as I click this, the next student's code is automatically going to come up. So it's almost like you have a stack of submission papers and you're just moving one and you get the next one right there. So fast grade is awesome. Again, it's part of our Pro Tools because it enables you to grade student assignments very quickly and see student code. If we have a solution code listed there, provide a grade, provide feedback, and then click finalize. Okay, so we've talked about the assignments, which was, or I'll say the roster, which was managing the section. The assignments was managing the content of the course. Course settings, we looked at due date and access controls to manage the flow. There are some other settings in here as well. Progress to track the progress, gradebook to actually look at grades and start grading. And then the last thing I want to point out is resources. So if I were to click on the resources here, it brings me to this page. And so again, for Arduino, all of the resources are free. So you want to click, make sure you have the Arduino course selected. And then you can look at lesson plans, problem guides, handouts, and there's some other information in here as well. First week resources I want to highlight because that's something, if you don't want to get right into the course right away, here's some just like top level, like growth mindset, kind of thinking big picture about the course in this resource. So definitely check that out. But the lesson plans link will have all the lessons for the course, and this will be obviously for the Arduino course. And then same with the handouts. Any handouts that are there will be listed. And all the problem guides, which were a little more detailed solutions with FAQs for each individual activity. You can see all the activities. So that's part of the resource thing. We have a very active and a very good customer support team. So if you click on the, oops, not that one, the toolbox, and if you go to support, we have a awesome knowledge base, which is a bunch of help articles on like how to, so like how to create a section, how to grade a student assignment, how to create my own assignment. That's all in the knowledge base. So I would start there for sure. And then we have a contact us if you want to actually reach out and ask a question. And our support team is there to answer your questions. So never feel like you're on your own, or if you're stuck, you can't figure it out. We have a lot of good resources here to help out. But start with a knowledge base, and then you can always reach out for us for help. And our support team is awesome. Okay, so drinking from a fire hose. There's a lot of information. The site, I mean, as I've been teacher, I've seen LMSs before. there's a lot here, and it's super helpful and super supportive. So definitely reach out with questions if you have them. So I'm going to bring back all the.
We're all back.
Oh, you're all back. Cool. Okay.
We're
So those who
all ready.
looks like
So
there's some
yeah,
people.
just skip. So there's going to be a lot of, you guys are going to receive this slide deck. You're going to get all these slides on a lot of those tools that Ryan just went over. So yeah, if you just skip towards the end, there's just about, I think, 2 links that we want to make sure we get you. So we can skip this one for now, since I know we want to get you out on time. So if you could take just a few seconds to fill out this survey. We always want to make sure that we're giving you information that's helpful for you, and any feedback that we can get always helps us for the next workshops that we run. So we'll throw this into the chat. And the last thing, if you need a certificate for attending today, our link for that is going to be Arduino-certificate. And you can just fill out your name and email, and we will send those out today or early tomorrow. So you can expect to see that. And thank you guys so much. This is obviously, of course, we're all so excited about. We just can't stop talking about it. So hopefully you got what you came for, and we look forward to seeing you and hearing from you this year. Bye, everyone.
Yeah, thank you so much. Have a great start to the school year.
Thank you. Bye-bye.